So let's dive in by looking at the first target. And what we know about this target is that it has a preset password. We don't know what form that password may take, but you might be able to figure this out just by looking at the code. We start out at the main function, and if we look through it a little bit, we can see that it makes a call to a function called initTerm, and then check password, and then it checks the result of check password, and if check password returns a 0, it's going to jump to 41162, and if it returns something other than 0, it's going to call open lock. So that means that if check password returns a non-zero result, we're going to open the lock. So check password is probably where we want to look next. So we look at check password, and we'll just go down through it a little bit. There's some stack manipulation. There's some jumping and comparison. This is probably a loop somewhere, and then it's loading up some data and calling prompt. And for check password, maybe this is prompting you for the password, and it's doing something. It's actually jumping immediately after that. It's jumping down to some other place, and then if we go a little further, there's another call to prompt, and also actually the place that the other one jumped to is right here. So no matter which call to prompt, it's going to end up right here, and it's going to then almost immediately call strcomp. And so that probably means that this strcomp is comparing the password with the password you entered with some other value. So a simple thing we could do here is I can set a breakpoint. I'm just going to hit B right here, and then I'm going to go over here and hit C for continue, which will cause the program to run up until it hits a breakpoint or it exits. So it's running, and it's prompting me for a password. So this is probably what the prompt function does. And I'm just going to enter foobar. I don't know what the password is yet, and it looks like it's hung. I hit the tab key and I pop back over to the debugger, and I see that we're sitting on the call queue to strcomp. Now we probably don't need to step through strcomp. What we need to do is figure out what two things it's comparing. And when you get into something like this, one of the first things you need to learn, in addition to the instructions of the processor that the program is running on, you also need to know what the application binary interface looks like. That is, how do functions get called? And in this case, in the application binary interface for the x86-64, the first two parameters to a function are stored in the RDI and RSI registers. And if we look over here in the registers window, the RSI is set to 402004, and RDI is set to 7FFFFFFD010. One of these two is probably the hard-coded password. So which one? Well, here's a clue. On the next line of registers, you can see RSP, which is the stack pointer, where the stack is in memory, is at 7FFFFFFD000. So the value in RDI is pointing to something that's on the stack. And often what's on the stack are things that come and go, because the stack grows and shrinks, and you usually don't have something that's hard-coded sitting on the stack. It's usually in a different area of memory closer to where the program is, because it's actually part of the program code. And so that suggests that maybe this RSI value of 402004 is pointing to the password that's fixed. So if I do VM for view memory here, and I do 402004, we look over here in the memory, and you have to count over because it's rounding the memory so that it's on 8-byte boundaries. And so 402004 is over here where this 40 is. So that might be a password. 40, it's all printable characters at L0 H0 M0 R at, and then 00 here, which is probably the null terminating a C string. So this could be it, at L0, H0, M0, RA. So what I'm going to do is I'm going to hit C to continue. So I'm going to make the program run again. And what's going to happen then is it's going to do the comparison of foobar that I typed in with this, and it's going to say that's not a valid password. And it's going to say, yeah, invalid password, 2 tries left. So now I'm going to try the password I saw hard-coded. At L0, H0, M0, R at. And when I hit enter, it locks up again because we hit the breakpoint again at the stir comp. And so I'm just going to hit C to continue, and that was it. That was the password. So I'm going to click on target 1 again just to show how we might have figured out this password without having to enter an incorrect password first. That is, can we do this without a breakpoint? So let's go back to check password. And we got down here to the stir comp, okay? And right before the call to stir comp, we see that we're putting RAX, the value in register AX, into RDI. And we're taking the value that's in an RDX and putting it in RSI. And one of the things we can see here, RAX has a value that's relative to RBP. Now, again, when you learn the application binary interface, and this is a little more complicated, when you call a function, let me go back here to the beginning of check password, which was up here at address 01189. It pushes RBP on the stack, so whatever RBP had, it's saving that, and then it's moving the stack pointer into RBP and subtracting 30 from the stack pointer. So what this means is it's when you subtract values from the stack pointer, you're adding space on the stack because the stack grows downwards in address. And so BP you could think of as pointing to the bottom of the stack frame for this function. And so what it's going to do is it's going to refer to variables relative to RBP. So you can see here it's storing something at -8 relative to RBP. So there's a variable at 8 locations away from RBP, and there's probably 24 locations away from RBP, and so forth. So what that means is when we go back down here to the stir comp, when we're doing -20 relative to RBP, that means that's a value that's on the stack. And likely what this means is the password that you type in is at this location that's hex 20 in front of RBP. And so that also means that the value that's put in RDX is probably the password that's hard-coded. And you can see it's doing this move relative to the instruction pointer because if the password is hard-coded, it gets compiled into the program somewhere around where the code is. And so this is the compiler puts it somewhere after the code, and it can find it relative to, it knows where it would be in memory at this point, and so it knows that the thing is at the current instruction pointer, which if you look 4011 F7 plus 2E82, it's really going to, the instruction pointer is really going to be pointing at 4011 FE when it does this computation. And so if you were to add 2E82 to 4011 FE, you will get, and it tells you right here in the disassembly, 404080. And so we want to look at memory location 404080. And so if I do view memory 404080, this doesn't look like anything. There's an @ sign, but and a space, but is that a password? Probably not. But there is a clue here. So going back into the disassembly, notice that when we call strcomp, we want to pass pointers to 2 strings. And when it calls this move here, it's actually taking this data at 404080 and putting it in RDX. So RDX is going to have a pointer. So 04204000 is a pointer. And remember that on the x86, the values are stored at least significant byte first. So the right hand side of the number is the first byte. So if we look at this in reverse and I hit VM and then write these numbers, I don't need to put the leading zeros. So I'm just going to do 402004. And if you remember, that was where we found the password in memory before. And so we can see again that that's at L0H0 and so forth. So we can actually figure out the hard-coded password just by looking at the call to strcomp and working backwards and seeing where it got its data values. And just for fun, I'll go ahead and show that I was able to do this without hitting an invalid password. So that's all it takes to find a hard-coded password, which might tell you that it's not a good idea to include, especially plain text, hard-coded passwords in your programs. But as you work through some of these exercises, you'll see that it's pretty hard to have a hard-coded password at all.